Hi, my name is Rasmus Jørgensen, and I'm researcher at scientist at Aarhus University, and I've been there for many years. But I had a gap where we did should we call it a bidirectional knowledge transfer between AgroIntelli and computer vision, and some of this know-how I gained there, I will share with you. You heard about safety sensors and how important that is and how it's handled. And now you also heard about how how the farmers are using it, or the consultants are using it to support the farmers. And Ole Green has told you about how the camera, the crop eye we developed together when I was there, is used for mapping crops and weeds. And I've used as an example from what I learned there, but it's the missing link in general. Why it's so important. We need sensors to tell us what the machine is doing. I've been doing this for many years, working within precision agriculture at Aarhus, or first at Copenhagen University, and then at Research Center Risø, and later at University of Southern Denmark. And lately, the thing where we got traction and funding was computer vision, using that for safety measures in a project called SAFE, or to detect weeds and crops and try to turn that into more sustainable management. And for the last 2.5 years, I was at Research Center Research, I was at AgroIntelli, and there I had one of my colleagues, Nima, with me, and our task there was trying to upgrade the robotic to have cameras, and especially cameras looking at the crop, we call it crop eye, and then turn it into maps you could use to change your future planning, as you've seen Ole presented. But the feedback from the farmers was, and that's, I think, general for robots. I just saw that Exceed has been covering 12,000 hectares in Australia, and talking about what they done there, they never mentioned the cameras or the surveillance and how it ensured that it wasn't doing something wrong when the farmer was not looking at it. And I think it's a general problem that you have a camera you can turn on and you can look at a video feed, but when you turn it off, there's nothing really looking at the quality of the work. You just expect that the quality is perfect. And that was also feedback from some of the farmers from Robotics, because Robotics now can go hours and hours and hours, but if the implement fails, there's nothing really telling you that it fails. And it's a general problem. So let's dive in. I hope what I'm going to talk about will be better than this. I tried to explain what I'm trying, the takeaway from my talk to DALI, or Dale, I think it's called, the ChatGPT imaging facility. But what has happened here is that it has really made the human high-tech with everything, but not done anything with the farming equipment. So I hope I can do better than this. In the past 20 years ago, 20 plus years ago, the state of the art, if we should look at that, was that the theoretical approach of site-specific fertilization, for example, was that you had a combine or other things, a soil map, then you did magic up here, and then you could tell the sprayer what to apply. It has been really hard to get that pipeline up running, so it's easy for the farmer. Then you upgraded it a little, that you had a sensor, the Yara sensor, for example, and then you mixed a map and what the sensor saw, and then you got you targeted your fertilization, or you just did it in real time like the Yara sensor did most of the time. But if you look at, and this is, you can see 20 years ago, the envision that you had some knowledge, you had a soil map, you had satellites, drones, flies, everything, weather data, the dream, and then you transformed that into site-specific seeding. That is beginning to work. Liquid manure, it's coming. Fertilization, at least you heard that it's being done now, or plant protection. So that was the envision, and it's 20 years later, we are beginning to have something where it actually works, and you have a flow which is acceptable for the farmer. So if we summarize it, like it was envisioned in 25 years ago, you had farm management, you had crop management, machine management, labor management, and then by magic. And here it was hot to say traceability. And we joked about that the reason we called it traceability was because we had no clue what to do with all this information, how to transform all the nice maps, yield maps, satellite maps into other than just nice color maps, to turn it into action. I was looking at if I could find anybody who had the same view or the same points and key takeaways as I'm trying to come with today. And I found this not so old publication saying that autonomy is cool, but data will be the real game changer for farmers. And I tried to do that at AgroIntelli, but time was not mature for it. I tried it many times, but even explaining it is like what you saw, the representation from the artificial intelligence was not really successful. But here, some of the points here is when the farmer is out there with his high-tech equipment like this sprayer, it could be a combine, the data it collects, if you utilize that, you will know so much more about your field so you can do better farming. And that's the next level, when we collect all this data and turn it into agricultural intelligence, like the name of AgroIntelli, and we turn that into action, reaction to optimization. That's where we really gain something. And that's not specific whether you have an autonomous tractor or you have your huge implement, which is 12 or 48 meters wide, going high speed, and the operator, he has no way of reporting what is happening there. But if the implement themselves report what it sees, not only what I'm doing or think I'm doing, but also what it sees, then we have something we can use for optimization. Here is a small video. Last year when we were testing that, we had a camera looking behind the implement, just what's happening. You can see that farm droid, I haven't seen it myself, but there is a camera where you can see what is happening. And that's kind of the same here. You can survey it if you have bandwidth enough. And that's a big if. You can also see where you are in the field, how it's progressing. There are some images here for the crop I had focus on. I'll come more into that. So all the cameras you can turn on and off, and you can get an idea of what's happening. Now it's the camera looking forward. You can look at and you get an idea of how the environment is, how it's doing. But still, it's a video feed, so the information density is relatively limited because a video feed is far from as good as a still image. Here you have an example of what I am trying to advocate for. This is when Robotics has done a job in the autumn at Copenhagen University. It has what it called a cross-track arrow. So that is reporting how far is the steering point or the robotic from what it's supposed to. And you can see the scale down here. So when it's blue to green, there's nothing problem. But when it's red, there's something for at least for a short period. There's also collected images, so we can also look at the images. So here you gain insight. Imagine you had a whole area which was green at a side slope. Then I would start to worry if that was the seeding operation. Because the next map when you do cleaning is assuming that you seeded correct. So here, that would be valuable information if you need to take action and change the route plan and do optimizations, to vary at least. Here is also what Ole has shown, that you can analyze the data and you can get an idea of how much dicot wheat there is, monocot wheat, and here's the thistle. So you can get intelligence you can use in your future planning. Here, and that's what I see in most, for example, systems, whether it's other robots or AgroIntelli, here it's in transplanted brassicas. You have the video feed, but you have not enriched it. Here I've done it, post-processed it and enriched it. The model is not used to these low quality images, but if I crop it and ask the model to analyze it, it can still find the crop. Here it's saying it's a wheat, but I have trained it, so it's saying this is one of the first iterations, but it will say it's brassica. And then you can use that, even the front eye. If I look here in this little area, I can still analyze it and get an idea of the crop and wheat density. But we are not doing that, and nobody's really doing that, trying to enrich the images in real time and use that as a continuous quality measure, so you can pause the operation if something is wrong. Here is another way to use the images. If you have always collect images, whether it's a tractor or robot, and you start to look at it temporarily, for example, the coverage of the crop, then here it's separated by a week. You can see there is a wide area. That's where there's not really a change during a week in the coverage, and here is a huge change. So here you can see, if I take images from that area, that the reason there is a change is the crop is growing, but in this area, nothing is really happening. So here the farmer gets valuable insight. And if you had weeds or other things, or satellite imagery, they have a hard time handling so sparse an area. So this is a lot better than satellite imagery. If you have a drone, it's an extra operation. Here we are collecting intel while we're out there anyway. Another case is that here it's the front eye and the camera looking behind I'm comparing. They're not having exactly the same viewpoint, but you can get an idea that there is a high density coverage here of crop. And here is some, when you look after, right after, it's lower. And the reason for that, when I look at it, is that something went wrong for the cult. It was one of the early adaptations. Of course, I use that because it's so seldom it goes wrong. But when it goes wrong, it really goes wrong. And here you need to analyze the image so the farmer is alerted, and if this is what we see, or the AI or the computer vision is seeing, it should pause or stop and ask if that is okay. And if you really put it on steroids, here we had a whole season where we analyzed images, but it's based on the front camera in front. So when it's here saying inter-row weeding, that's before we did the inter-row weeding. So when we look at it down here, that's the result. And we are looking within the crop band and between the crop bands. So you can also look at the difference. And of course, you don't expect the first time you do inter-row weeding, and this is before you have done it, you don't expect any difference. And that's also showing that there's not really a huge difference. I have other examples where you can see there is a difference, because when you seed, there will be a difference to some extent, because the seeder wheel is compacting the soil. So in fact, even though you haven't done any weed control, you have more weed in the bands. Here we also, initially we thought in this trial that the best thing is to do the mechanical weeding, because if it's raining or we got troublesome weather, we cannot really get optimal conditions, and then we spray. But here it's clear we should have band sprayed first, because you can see as season goes that the band spraying area here, you can see there's a lot more weed in the band compared to where we did it mechanically. So the learning from this, and that's the learning you can get as a farmer looking at this, if we make the interface and the right tool, is that just because implemented out there, it's sharing what it sees, it's sharing what it's doing, and that you can use in your future planning. And the strange thing here is that if you look at a combine, as I shared at LinkedIn today, after I read the article from Trimble, combines had a loss monitor for decades in real time. But the only thing, I tried to Google it, it's really hard to get a loss map. Why are the companies not sharing it, or why haven't the farmer realized the value of having a loss map? Because the loss map shows you where the combine had problems, and the combine can never do it perfect. Imagine you are going out and you have close to a forest, high tree line. There often the crop is not mature or ripened enough, but you harvest it anyway. That would show as loss or as quality if you look at that, all the things Agro, for example, is looking at, or class. If you share that map, the farmer gets wiser. Or if you have a drop area in your field and the grain has not grown, they're really hard to trace and they're very light. So there you will have a higher loss. But that will teach the farmer how it looks. Or if you have a chaff spreader, or you're chopping your straw and spreading it, and it's really windy, you cannot fulfill an even distribution of what you're chopping, and you're documenting it, and the farmer will know it, and then he can optimize. This is my point. Why are we not documenting? Why are the implements not documenting what they're doing? It's not bad. It's bad if you always are doing wrong. But if you're doing wrong because the conditions are not optimal and the farmer decided we have to do it now, period, he also needs to be taught the consequence of what he did. And then say, okay, I know, but that was my decision. But okay, it has a huge impact in this area of the field, so I need to put more attention there now. That is what we can give the farmer, or should give the farmer, when we are producing our implements. I hope that's the takeaway. There was a Danish article in Landbrugsavisen. Now I just use Google Translate, but it was, keep an eye on your robot. It doesn't have eyes in its neck, and that is a problem, because something will fail for sure. And if the robot is just continuing and you build up trust, John Deere published a publication 20 years ago about a mower, and the idea was the people should survey it. But what happens is, people are people, me included. When the robot has done that, or the mower has done that, for example, a week, no problem. Then people just leave it alone and do whatever they're doing. And the second they do that, something will fail, and it can really have consequences. Imagine this one, you leave it for a whole day, not surveying it, and something with the GPS, when we think of Putin and the war, there's been some jamming, so it's drifted. So it has, for 8 hours, destroyed half of the crop. That would be really, really bad. So it's so important, don't trust blindly, and enable the robot to verify that the quality of what it's doing, to which extent it's fulfilling its mission. But then utilize that capability in your future planning. For example, if this one was surveying how well it was weeding or cleaning, then it could utilize that for the next weeding operation. So if it's really green in an area, it could prioritize troublesome areas. I think that was my talk, and hopefully that will help you with a better takeaway than what the chatbot got out of it. Thank you.